For years, the story of AI has been the story of going bigger. Bigger models, bigger datasets, bigger breakthroughs. The dream was simple: build a universal neural engine, a kind of artificial brain that could handle any task we threw at it. Translate a paragraph, solve a math problem, write code, diagnose a disease, the same model would do it all. And in many ways, the large language models we have today prove that dream wasn't foolish. By scaling up dimensions, we discovered emergent abilities. Suddenly, one model could chat, summarize, tutor, and create, all without needing separate training for each task. It felt like the first glimpse of a universal brain. But reality soon set in. These large dimensional models can generalize across many conversational tasks, but they are not strong enough to generalize across the entire messy landscape of real-world work. In practice, we still end up fine-tuning and customizing them. A model that's brilliant at open-ended conversation may not be precise enough for a legal contract, or efficient enough for a robot arm, or reliable enough for clinical decision-making. This is where the new paper, "Small Language Models Are the Future of Agentic AI," offers a refreshing perspective. The authors argue that instead of one giant brain doing everything, we need a division of labor. Small models are sufficiently powerful for many subtasks, far more efficient to run, and much cheaper to deploy. They can be scattered across devices, each performing a narrow role, while the larger models remain reserved for high-level reasoning and communication. The paper outlines 3 key points. First, small models are good enough. Second, they are operationally suitable. They run fast, can be embedded in phones, robots, or laptops, and don't demand supercomputers. Third, they are economical. Instead of burning massive amounts of money and energy keeping a giant model online, you can deploy lightweight agents at scale. The researchers even suggest a practical method. Take today's LLM-heavy agents and refactor them, pruning out the oversized parts and replacing them with smaller specialized models. The result is a hybrid system, leaner, more modular, and closer to how real organizations or ecosystems function. But here's the bigger picture. This debate is really another angle on how we imagine AI itself. At first we dreamed of building one powerful brain, but now we realize that the universal brain is still far away. So we compromise. We build systems where large models act as the brain, doing reasoning, making sense of complex instructions, communicating fluently, and we let smaller models act as the hands and legs, doing the specialized task-oriented work. In fact, you could imagine 2 types of language models in the future. The first is the super-large generalist model, a brain that can adapt to new domains, communicate with humans or machines, and reason across unfamiliar problems. The second type is the specialized model, not built for chatting or generality, but for deep expertise. These models are like the hands and legs, fine-tuned for action, built for efficiency, and more reliable within their narrow roles. Together, they form a body. The large model is the strategist, the thinker. The smaller models are the doers, the executors. Neither is complete without the other. And maybe this is the path forward. Not choosing between large and small, but understanding how they complement each other. Large models for reasoning and generalization, small models for action and specialization, the brain and the body working in harmony to make agentic AI truly useful in the real world. So here's the question I'll leave you with. When you imagine the future of AI, do you see it as one giant brain doing everything, or as an ecosystem of brains, hands, and legs, each playing their part?